It is the second part of section 5.4, Random Foresters, Multiple Decision Trees. Random foresters are an ensemble learning method, which means that the algorithm uses multiple classifiers. The algorithm trains multiple decision trees so that at the test stage, multiple outputs will come out. Then the algorithm tries to choose the model of the predicted classes in classification and using majority vote, and in regression and it tries to choose mean value out of predicted values. The random foresters have gained huge popularity in machine learning during the last decade. The reason is their good classification performance. That means it is accurate. And scalability, that means it is efficient in computation and easy of use. The idea behind random forest is to average multiple decision trees to enhance the robustness and generalization performance so that it becomes less susceptible to overfitting. Each decision tree can be easily overfitted. Here we have a summary for random forest algorithm. Step 1, draw a random bootstrap sample of size n. Here bootstrap sample means that we sample and data set of size n, data subset of size n with replacement so that each subset may have some data point again. Now, for the sample, we train a decision tree and we repeat 1 and 2 k times so that we'll grow k decision trees. Now, at the test stage, we aggregate the prediction by each tree to assign the class label by majority vote. It's so simple. By using a subset of the given data set, we try to grow a tree and we repeat k times. In step 2, when we are growing a decision tree, rather than try to get best split and evaluating all features, rather than this one, we try to choose a random subset of features of size d. And here, original data set is here now. That is now number of feature is m, capital M, and we have n points. So when we train a decision tree earlier, we try to here now evaluating the split, and so that information gain for each feature, and now for each feature and each data point we did that. Now rather than that, we may try to choose random subset but with a replacement and random subset of the features so that it can be much faster. But because we have many decision trees, even though we choose a subset, random subset, it'll be okay. So we choose the random subset of size d. Okay. Now here we have remark. A big advantage of random foresters is we don't have to worry about choosing good hyperparameter values. For example, the n, the sample size, once we choose a smaller n, then here randomness will increase. While if we choose bigger n, then here now the algorithm becomes more here overfitted. Okay, so we can choose n and around the size of the original training set, as in the most implementations. But you can choose, for example, about half of the original size, or a smaller value. Now here, for the random subset of the features, the default value is square root of m. So for example, the m is around 100, then you can choose here d is about 10. So that 10 subset, 10 columns out of 100 columns, randomly 10 columns will be chosen, and using that we'll try to grow a tree. So these two is not so much sensitive. However, for k, the number of trees, you have to pay attention. If you choose too small, then the performance is not so good. If you choose large, then the performance becomes better. However, it is more expensive in computation. So you can choose k. So it's not really here requiring some complication. Just depending on your the task, you can choose k appropriately. Then you can enjoy good performance with the enough efficiency. This method, the random forest, is well working and very popular because of these features. Okay, thank you.